morning. Uh, this presentation is about autonomous driving and it's presented by Kinugaba John Joel. This is the table of contents. There's the introduction, open database used, factors considered for the data set, features of the data set, and others. The introduction, autonomous driving. This is where vehicles use artificial intelligence to automatically drive themselves, which reduces risks of accidents because most accidents are caused by drunk drivers and reckless driving. Autonomous driving can really reduce this risk by using machine learning and artificial intelligence. A data set is a collection of various types of data on digital format like images, text, audio, numerical data, among others. So the open data set I used for this presentation is called Waymo Open Data Set. The Waymo Open Data Set includes data collected by Waymo vehicles during driving millions of miles in Phoenix, Arizona, Washington, Mountain Views, California, and San Francisco, and it covers day and night, dawn and dusk, sunny and rainy days in various cities, and data collected while driving suburban environments. The data samples is divided into 1,000 driving segments, and each segment continuously captures 20 seconds of driving data through sensors installed on Waymo vehicles. Factors considered before selecting Waymo: 1. Motion prediction, interaction prediction, occupancy and flow prediction. 3D semantic segmentation, 2D tracking, and real-time 3D detection. The 5 important features I considered in Waymo. First one is real-time 3D detection. Real-time 3D detection is a variant of object detection which focuses on lowering the latency of models in autonomous vehicles, which can make use of LiDAR data and camera images to predict 3D bounding boxes for objects in a given scene. There's labeled data, labels for objects, vehicles, pedestrians, cyclists, signs, high quality labels in LiDAR data in 122 segments. 3D object detection. There is motion prediction. We are given the 1 second history of all agents on the corresponding map and asked to predict the position of up to 8 agents and 8 seconds into the future. Then the 3D semantic segmentation. This is a fundamental machine learning task for a range of applications including autonomous vehicles. It aims to delineate different homogeneous objects in a scene using LiDAR, points, clouds, and 3D image sensors. Now this is the Bayesian theorem. The Bayesian theorem states that the posterior probability or the probability of an event given the new information received is proportional to the likelihood of seeing that new information multiplied by the prior belief. It is used where the probability of occurrence of a particular event is calculated based on other conditions, which are also called conditional probabilities. Naive Bayes. The naive Bayes is normally known as a classifier. It's a probabilistic machine learning model that is used for classification tasks. It's based on the Bayes theorem. The Bayes algorithms are mostly used in sentiment analysis, spam filtering, recommendation systems, etc. They are fast and easy to implement, but their biggest disadvantage is that the requirement of predictors to be independent. This is a continuation of the naive Bayes algorithm. It is called the naive because it assumes the occurrence of a certain feature is independent of the occurrence of the other feature. Types of the naive Bayes classifier: there is multinomial naive Bayes, Bernoulli's naive Bayes, and Gaussian naive Bayes. Bayesian network. A Bayesian network is a compact, flexible, and interpretable presentation of a joint probability distribution. It's also a useful tool in knowledge discovery as directed cyclic graphs allowing presentation causal relations between variables. Bayesian networks are widely used class of probabilistic graphical models. They consist of two parts: structure and the parameters. Difference between Bayesian theorem and naive Bayes. Naive Bayes assumes conditional independence where Bayes' theorem does not. This means the relationship between all input features are independent. The difference between Bayesian networks and naive Bayes networks. A Bayesian network model. A Bayesian network models relationships between features in a very general, while a naive Bayes classifier is a simple model that describes particular class of Bayesian network where all features are class conditionally independent. Because of this, there are certain problems that it can solve. These are the references. It's the end of the presentation. Wakapu dakika bubiri.